I'm a I'll start later. Good day, everyone. My name is Anu Chaudhary. I'm a PhD student at Victoria University of Wellington in New Zealand. So I welcome you all to this last tech talk of this year, which is on drilling for geothermal opportunities for technology cross-pollination. And the talk is presented by Danny. So I welcome Danny to this talk. So about Danny, I would like to introduce Danny here. Danny is a business leader, innovator, and entrepreneur focused on building companies and leading change efforts. He has diverse experience in engineering and management in geothermal energy, oil and gas, operations, well construction, subsurface engineering, capital planning, and optimization. Danny is a co-founder and managing partner of Criterion Energy Partners, an independent exploration and production company focused on developing decentralized direct geothermal energy projects to help commercial and industrial consumers reduce their emissions and improve their operating efficiency by providing clean, reliable baseload energy using heat from the earth. Danny held his position of increasing responsibility in engineering and management at a Fortune 500 company, Anadarko Petroleum, and a private oil and gas company, Renewable Energy Sources. He has led energy exploration and development projects in the United States and Africa, and holds an MBA from Rice University and a Bachelor's of Science in Petroleum Engineering from the University of Oklahoma. So I welcome you, Danny, and I request all the attendees to put your questions in the chat box, and questions will be addressed after the talk by the speaker. So the floor is all yours, Danny.
Thanks, Anu. Appreciate that, and I am going to share my screen. Thank you for the introduction, and happy to be here, and always happy to be sharing with students, and then the student chapter of Geothermal Rising. I was very involved in leadership positions when I was at university in various organizations, industry organizations, and always appreciated having having good talks and good speakers. So I'm kind of passionate about giving back in that sense, and really excited to be here. So thanks, Anu. Can you all see my screen?
Yes, we can.
Okay, great. So today I'm here to talk about opportunities for cross-pollination and from oil and gas and into geothermal, and really from geothermal into oil and gas potentially as well, and kind of share some thoughts around how at Criterion, we're thinking about technology and how that's going to be deployed into what we're calling next generation geothermal energy projects, and really just excited to kind of share a whole bunch of that information with you, and also share a little bit about the company. So I'm going to assume that everyone is not 100% familiar with geothermal energy development, although I know that there's probably some experts in the audience as well. And so bear with me if some of this is somewhat repetitive, but I did want to have some basic kind of discussion around what is geothermal energy and how is it applied, and how are we thinking about addressing the marketplace at Criterion. So again, the title is Drilling for Geothermal Opportunities for Technology Cross-Pollination, and I promise to get into the technology piece in more detail as we go on. Okay, so renewable energy is the future, and I'm sure everybody on this call knows that and appreciates that, and I just really wanted to put this out there that there's a surge in renewable energy developments and investment, and as we basically move into the next the next chapter of energy, it's going to be in renewables. And for the most part, when people talk about that, they think about wind and solar as being key parts of that. Maybe there's some other technologies, hydro power, maybe nuclear gets lumped into there. But, we really think about, opportunities to scale that and to address the challenges of the future, and think that geothermal is a key part of that future. And there's a host of reasons why, and I'm going to talk a little bit more about that. But look, by 2030, there needs to be $4 trillion of investment in renewable energy technologies and in renewable energy development. So it's just a tremendous task ahead of us to enter into the energy transition and achieve the scale and impact that's needed. And it needs all of us to do that. So it's pretty exciting. It's a pretty exciting time. Those challenges are opportunities, and yeah, excited to dig into that a little further. So everybody that knows anything about geothermal knows that it's just awesome, right? Geothermal energy is a fantastic resource. It's clean. When it's developed in a responsible way, it's renewable. It's base load power. It's always on. Has high capacity factor. It can have features on a grid system, on a microgrid system like black start and peak shaving capabilities, dispatchability even. There's just a lot of great things about renewable, always on geothermal energy. And the real challenge has been is that it's always been constrained geographically by these heat anomalies in the earth, and a lot of that has to do with the tectonic, the plate activity, and these areas on the earth where you have the plate margins coming together and elevated temperature gradients near the surface of the earth, and sometimes at the surface of the earth. So that challenge has limited the scale and the growth of geothermal in the sense of kind of power and heat, direct heat application on a large scale because of this anomaly. Now, there's some technologies out there that are proven that exist today, and when combined, we see just a tremendous opportunity to deploy these technologies to develop geothermal in new markets today. And those kind of three areas of technology are really horizontal wells, largely on the back of oil and gas development, multi-stage completions, which is also another technology that's been developed and refined in the oil and gas industry, and binary organic Rankine cycle generation technology, and that's been developed and perfected by a lot of different industries. So combining these three technologies, we see a huge opportunity in front of us to deploy geothermal in new markets today. And in fact, we have a project that we're advancing here in Texas and looking to drill a well next year and develop using these three technologies, and are quite excited about that. So, in addition to those three technology areas, Criterion has developed some technologies to help accelerate the deployment and also minimize the risk of deploying into new markets and new geologies. And that includes things like fluid systems for managing kind of the permeability patterns within the rock between wells as we go to develop the reservoir systems. Fluid systems that enhance the thermal conductivity, so nanofluids that have the capability to have a higher heat capacity than just in situ brine. And then also a screening tool that allows us to identify the best resources and the location of those in the subsurface environment, but also the demand centers and the off-takers who need not only power, but direct heat for their manufacturing process or their commercial facility. And in addition to that, there's a lot of industries out there that have a large amount of emissions that need to be addressed as well, and that tool allows us to find those prospects and build them into our portfolio in an efficient way. And then finally, the well and completion designs that we've developed are really aimed at maximizing production and minimizing the overall drilling and completion cost, which is a very capital intensive part of the development. So the next handful of slides are kind of an overview on geothermal energy, and this is maybe the part that's a little bit repetitive for some, so I won't spend a lot of time on these slides, and we'll move pretty quickly. So what is geothermal energy? I think everybody that's a part of Geothermal Rising has their definition for what geothermal energy is, but I like to describe it as that there's this radioactive heat source that is the core of the earth that just continues to generate a tremendous amount of energy from the core, and as that energy works its way up into the surface, and it's just it's virtually inexhaustible, right? Because it's so large and what it is at the center of the earth. And as that energy works its way up to the surface, there's an opportunity to capture that in the form of thermal energy and convert that thermal energy into all kinds of things like electricity or raw materials or products that can then be utilized in a way that's efficient in the marketplace. So lots and lots of end uses for geothermal energy. I'm sure that most of you are familiar with the wide variety of applications, but really, we have just a huge opportunity to apply the assets that come from geothermal energy development into so many different industries and markets. And when we think about what's going on in the geothermal space, there's so much excitement and so much interest in next generation geothermal, conventional geothermal, geothermal heat pumps, right? That can be deployed in residential and commercial applications. There's just all this really exciting stuff that's happening in the geothermal space. And quite frankly, in the world, right? In the world of renewable energy and energy transition. So, it's really an exciting time to be in energy, period. But I'd say more significantly, it's really an exciting time to be in geothermal. So when you kind of look at the types of geothermal energy that are out there, there's a few different sort of applications, right, that are often described in various ways, and we get the question, like at Criterion a lot of times, like what are you guys doing? Are you guys doing EGS, or are you developing conventional fields like in other parts of the world, or in the Western US, or in Iceland, or East Africa, Indonesia, and so forth? Or are you guys, are you doing enhanced geothermal systems? Closed loop systems have been getting a lot of attention. There's a lot of different applications, and everybody wants to kind of put your company or your technology into one of these categories. And what's interesting is that there's a lot of hybrids now that are out there that combine a lot of these different approaches into one. But from Criterion standpoint, just to help kind of orient everybody in terms of what we do, is we generally focus on kind of the middle of this slide here, and what's often referred to as enhanced geothermal systems. However, outside of what's typically been done in EGS with basement rock and creating fractures and having those fractures dominate the flow regime, we're really focused on sedimentary basins where there's a significant amount of existing permeability in place, so we don't have we don't have to create these huge stimulations and worry so much about controlling those permeability pathways. We've got some existing reservoir rock properties that are beneficial. So really, going into kind of the application of geothermal energy and where we're thinking about applying our systems and the target segments or subsegments that we're really focused on. There's a few of those that we really like, and to be quite honest, our team went through an exercise of looking at customer discovery and how do we apply geothermal everywhere in the most efficient ways, and what's our beachhead market, and where does this make the most sense, and where can it be the most cost effective. And these 6 subsegments were ones that we all got pretty excited about and got some good customer feedback initially on. And I'll just list them. That's distribution centers, which has just grown in size and breadth in many places in the world with the global logistics supply chain, LNG facilities, steel manufacturers, beverage manufacturing, power and utility retailers, and distributed energy projects is really what that segment's focused on. And finally, chemical manufacturers. And actually our primary focus for our beachhead market is chemical manufacturing. And when you think about it, a lot of these customers aren't just using power. They're also using a tremendous amount of direct heat or cooling. And that combined heat and power sort of model is really critical from the standpoint of what we think makes for a really good application of proven technology and to go deploy geothermal energy today. So I'm jumping around a little bit here, but what is kind of the binary ORC power plant design? I'm sure many of you are familiar with this, but really the concept there, right, is to circulate produced fluid, geofluid, geothermal brines, typically under pressure through a heat exchanger system, which is then used to kind of boil a working fluid that's at a lower, that has a lower boiling point than water. And so something like butane, for example, would be on the other side of the heat exchanger, and that fluid would be used to actually flash into steam, and that steam would drive a turbine, which would then drive a generator and produce power. So most of the applications that we're focused on today are this binary ORC process, and they can be really quite efficient for low to medium enthalpy resources, which is what we're primarily focused on. And then as far as the direct use application is concerned, we can either develop these systems in a cascading format where the fluid that's being run through the primary heat exchanger to run the ORC process can then be used for direct heat application, or we can develop the projects in parallel where you have a manifold system that deploys some of that produced fluid from the wellhead into a heat exchanger that powers, that feeds the ORC power process, and the other side of that system, which goes to a direct heat application. So here's just a quick picture of a geothermal power plant, and I'm sure almost everyone has seen this before. This particular facility is an ORMAT facility, and you can just see the various systems here: the substation, the power interconnect, the condensing systems, the piping systems that move heat between the wellheads and throughout the facility, and back. Through a condensing process to be recirculated through the heat exchanger, and really it's quite a neat project overall, and has a relatively small footprint compared to a lot of other renewable energy technologies. So what's really exciting to me, and what I often get to speak to people about is where is the geothermal market headed in terms of the number of wells and the amount of development in both capacity and scale are expected out into the future. And so this chart here actually has a forecast of the number of both the number of wells on the left hand side and the total capex in millions of dollars that is expected to be spent out over time. And you can see that it's been relatively flat over the last couple of decades, and picking up somewhat here over the last 10 years. But really the forecast out into the future is that the amount of wells is going to increase by several orders of magnitude, and also the amount of capex that's being spent is going to increase quite substantially as well into 2023. And this really goes back to the IEA report, which indicates that this tremendous amount of investment needs to occur to reach these net zero goals by 2030 and even by 2050. So the amount of the well count that's being drilled for geothermal today is quite small, especially when compared to the oil and gas industry. And even looking at the forecast here by 2030 of let's call it $4 billion of well capex, we actually think that needs to be significantly higher. When you look at like the U.S. Permian Basin, one of the most active unconventional oil and gas basins out there, they're forecasted to spend like $20 billion for developing the Permian Basin for drilling completion capital for 2022. So when you think about what this is relative to where oil and gas is today, or historically, this is still quite a bit less than what we think it needs to be for geothermal to be impactful. So we've really been working on our own forecasts and our own models of well count and the number of new wells and new projects that need to come online to achieve impact. And we're trying to jump up and down and tell everybody that those numbers need to go way up, and I think they will. I think the forecasts that are out there today are really underestimating the growth of geothermal energy, and I'm certainly biased, but I've seen under forecast before, largely in the unconventional oil and gas space here in the U.S. and I think we're on a similar trend for what those geothermal forecasts are today. So there are tremendous forecasts that have been put out there by the U.S. DOE, and the Geovision Report actually has indicated that they're expecting under a few different scenarios just this tremendous increase in the total capacity of geothermal energy. And it's easy to show a massive increase when you're starting from such a small baseline. But I think even prior to the new energy environment that we're in today, geothermal is really forecasted to take off, and this is on the back of new technologies, right? Taking new technologies, applying that to EGS systems, applying that to direct use applications for geothermal energy, advanced geothermal systems, closed loop geothermal systems that are being talked a lot about today, are another technology here that is actually expected to take these forecasts even higher. And so I think the takeaway here, right, is that applying new technologies in these cases of I think the BAU is business as usual, and then TI is I believe stands for technology improvement, and those new technologies are really expected to propel geothermal into a place where it's providing capacity that really is impactful and significant, and that's where it needs to go. So I was really taken aback recently in looking at a report by a firm here out of Houston, Tudor, Pickering and Holt, that basically indicated how significant the energy transition is for the globe. And this path to net zero is easy to talk about, but the task at hand is just so massive that it's really unprecedented and just such a huge challenge for the entire globe. And it's going to be messy, right? I think a lot of people have talked about it at this point. It's not going to be a straight line path. It's going to be a lot of work by a lot of folks. But I think what like this chart here really seems to indicate is that we're just going to have this massive growth in solar and wind, and that's going to allow for the reduction of fossil fuels in a big way. And I think what these forecasts are missing is that wind and solar depend on the weather and are intermittent, and they're fantastic technologies and absolutely need to grow and be deployed everywhere. But we need a renewable baseload energy source that can scale significantly beyond what renewable sources that we have out there today. So I think in my mind that's really the story for geothermal, is that the wedge is much bigger than what the forecast show, or will be much bigger than what the forecasts show, and maybe that'll help make up for some of the just massive growth that's shown for wind and solar when you think about balancing out the grid system and the energy supply. So I want to get into cross-pollinating technology for geothermal, from oil and gas into geothermal and vice versa, and talk about this concept a little more specifically. And really, I think the reason why this is an important topic is that reducing well cost and increasing the output of geothermal wells is really going to occur, in my opinion, largely from cross-pollinating technologies in oil and gas, and that's just the key to unlocking new potential and new markets and new geologies for geothermal. So what's this concept of cross-pollination? I don't know if everyone's familiar with using that term, but kind of a couple of slides here on what that means in biology, and kind of what when you take pollen from one flower and apply it from the same species into another versus into different species, then you kind of get this new species, right? And so if we take oil and gas technology and combine that with conventional geothermal, we kind of get this geothermal 2.0 is sort of the concept. And is this cross-pollination or hybridization? I'm not really sure. Not going to get into that in too much detail, but really, when I think about what we're trying to do at Criterion, it's a combination of taking what's been developed in the unconventional oil and gas space, and the conventional deep water oil and gas space, and the conventional geothermal space, and combining that all into one. And that's really the technology, those technologies that we're looking to deploy into Geothermal 2.0. So why is it important? And there's some great research out there that shows how these breakthrough opportunities happen largely on the back of combining technologies from different industries and into others, and what the potential of that has in terms of innovation. I'm not going to spend a lot of time on that, but look, it's proven science. This is a proven strategy to achieve results and achieve breakthrough innovations. So actually, cross-pollination is happening today in the geothermal space and also in the oil and gas space. you know, from technology, from the technology industry and adopting big data and analytics, AI systems, all of those things are really you know, taking place in drilling and completion technologies for both geothermal and for oil and gas. And then also you have projects like Utah Forge, where you know they're taking technologies from oil and gas industry and applying them in that application there to develop an enhanced geothermal system. And this is really a big DOE project that's been underway for a few years now, and that's looking to advance and study enhanced geothermal systems and both the drilling and completion designs and the reservoir management strategies for maximizing that opportunity, which is actually in Utah and on kind of the western side of the U.S. And so this concept of cross-pollination is already taking place. But you know, the DOE and the Forge group has published a lot of materials. It's a great resource if you haven't had a chance to go to the Utah Forge site and look at the data sets and information that's out there. There's just a lot of work that's being published by the group, and one of the things that they've talked extensively about, you know, in terms of what's required from an R&D standpoint to really advance enhanced geothermal systems is addressing the stimulation, right? The well completion and stimulation design, and getting that to a point where you have higher recoveries from these wells, higher flow rates, higher deliverabilities. And then the fracture control, you know, one of the big key challenges that's come up with, you know, enhanced geothermal system tests in the past is this concept of, you know, one fracture or a few fractures kind of dominating the flow regime of the wells. And so you're not getting the contribution from the entire completed zone. And if that's a horizontal well, that you're not getting contribution from the entire lateral. And so, you know, that's resulting in thermal breakthrough and temperature degradation. And if we can address those high permeability pathways and those highly conductive fractures, we can get more contribution from other fractures and increase the residence time of the fluid in the reservoir system as it's circulated between the producer and injector. And then from a reservoir management standpoint, really designing these systems as you have changing dynamics, changing chemistries over time to continue to produce at high rates without having significant thermal degradation is a huge challenge in an area of research and focus. So, you know, going a little bit further on what are the kind of key barriers for next generation geothermal, and you know, technical barriers are absolutely out there, but there's more. We've already talked a little bit about the technical barriers, but there's policy and market barriers, the adoption of these technologies in places like Texas. You know, it's a lot of times we talk to prospective customers and they say, wow, I had no idea geothermal was even an option, because we just haven't ever really put the resources and energy and effort into developing it in a place like Texas. There's been some work that was done by the government years ago, but outside of that, there's always been cheap, abundant energy resources here, and it's just not something that's been looked at or been incentivized by policymakers, both at the kind of state and federal level. So those incentives are key for any industry. It doesn't matter what you do. The government you know, needs to establish a framework that's both appropriate and facilitating to encourage that development. So that needs to happen in markets and in governments and places all over the world. And then just creating awareness. You know, our team spends a lot of time doing education on what geothermal is and what it is we're trying to do, and breaking down perceptions of this is too risky, this is too costly. I don't understand what geothermal is. There's too many applications. It doesn't make sense to me. All of those things are really, really critical. So more specifically on the EGS side, when we think about addressing some of the challenges that were outlined by the Forge project, in addressing some of the stimulation challenges, specifically like downhole equipment, right? That's designed to drill horizontally and drill at very high temperatures, right? Drill deviated wells at high temperatures, both the equipment that's required for steering the bit and achieving horizontal well bores in large diameter holes, and the tools that are required for geosteering. And that's everything from kind of LWDs to standard communication tools, right, that need to communicate back to the surface. And then again, going back to the reservoir management component and achieving the high rates and maintaining those high rates over time, in order to kind of justify the development cost of the facility and the power plant and everything else that needs to be built. It has to perform for an extended period of time, 20 to 30 years to really justify that cost, and that's absolutely critical. And then I've already kind of mentioned, talked a lot about the thermal breakthrough effects and mitigating some of those effects of having temperature degradation and one or a few fractures kind of dominating the flow regime. And at Criterion, we're designing some fluid systems and reservoir management strategies to address those challenges. So next, I want to talk real quick about Criterion geothermal systems and what we're doing to kind of advance next generation geothermal. So our systems are really designed to replace fossil fuels from behind the meter and replace or improve reliability of energy supply and improve resiliency from the grid. And that's done by co-locating with these facilities that consume large amounts of power and heat, and being on-site generation, so that they control both their energy supply and their emissions. And so the kind of sweet spot for us is 5 to 40 megawatts, and we generally target a 30-year life facility. The system is engineered in the subsurface, and that's, again, the drilling and completion design is highly engineered to maximize recovery and minimize the cost. And that's really the key part of the technology and the approach. And we're targeting customers and markets that need both power and direct heat, and that business model is important for achieving the economies of scale and the cost and price points that are needed to go deploy these systems in competitive markets like Texas. And then finally, the smart microgrid approach to be able to take the molecule and apply it to the highest value opportunity, whether that's generating power for the facility on site, or direct heat for the manufacturing process, or even selling that power into the grid when prices are favorable to do that, is a key part of what we're aiming to do. So I'll get into some of the specifics here, and I'm going to try to move as quickly as I can. I don't want to run out of time, but again, our systems in the subsurface are effectively horizontal oil and gas wells, but for geothermal, and they're really designed to be fit for purpose geothermal producers and injectors that can achieve the high flow rates that are required to produce commercial quantities of power and heat for an extended period of time. And so some of the things that are hallmarks of our system is the horizontal wells. We focus on high well integrity. We're not looking for the lowest cost, the absolute lowest well cost. We're looking for the best kind of value out of that system, and usually that means investing in tools and technologies that can deliver good well integrity. Our injection wells and the injection strategy is actually critical to the system in terms of minimizing the parasitic friction loss and ensuring that we get the reservoir support, the pressure support that's required to maintain deliverability, and can continue to operate for an extended period of time. So just finally, I want to mention, we're really in this design and optimization stage for our first project, and working to drill our first well in 2022 here in Texas. And going back to our beachhead market and some of our target customers, we're focused on chemical and LNG facilities today, and are looking to deploy both heat and power to those facilities. And the first well in the first phase of the project that we're developing is targeting around 5 megawatts of electricity, or maybe slightly less than 5 megawatts of electricity, with up to 10 megawatts of thermal direct energy being supplied. And we're basically fixing to go out an RFP for services here in the next few days to drill that well in the second half of next year, with energy production occurring in 2023. So I want to dive a little bit deeper into renewable energy from oil and gas technologies, and this concept of cross-pollinating, because I think it's really important to just hit home on this theme. So when you look at both wind and solar, and taking kind of the holistic or historical approach rather to studying this, when you look back over the last 10 years, the cost of wind and solar has just decreased dramatically, and that's been really pivotal in terms of deploying those technologies to new places, new markets, and to achieving some of the goals and objectives that are being set today for net zero targets. A lot of this occurred through government facilitation, technology improvements, and adoption. A lot of the things that, and then just through sheer innovation and hard work of people, right, and engineers and business leaders and technologists and so forth. So this story is really great, and I think geothermal is in a place where wind and solar were say 10 years ago, right? And I think we're poised for a similar push. So actually, the story in unconventional oil and gas is not all that different when you look back 10 years ago. A lot of unconventional oil and gas development really started to take shape in 2000, late 2008, 9, 10, 11, and started to achieve scale over the last 5, 6, 7, 8 years. And again, very similar story in terms of driving down cost and achieving scale, and has allowed the U.S. to become quite dominant in oil and gas production. And our team is largely come from oil and gas, and we're looking to deploy the same strategy and the same techniques that we did to drive down the cost of drilling wells and completing wells, and improving the overall performance of those wells in the same way with geothermal. So the team has looked at has gone through a number of workshops and looked at various technologies and in a variety of areas, and has come up with a technology roadmap to achieving a levelized cost that can be competitive in places like Texas and in other parts of the U.S. and even the world. And so, we look at kind of levelized cost, historical levelized cost, and these are U.S. figures, I believe. And so, we see a path to getting to $45 a megawatt, and even less when you combine the direct heat component where that can be applied. And that makes geothermal energy very, very competitive with other renewables when you consider the cost of storage and even gas combined cycle, which, I think achieving cost, lower cost to drive scale is ultimately what has to happen to get there. So we're not the only ones that see this opportunity. This is a report from Wood Mackenzie, who basically has come out and said that they see a path for geothermal getting down to a cost that's really very, very competitive with other technologies, and that's really even before considering the cost of carbon, right? When you add the cost of carbon, and carbon capture and sequestration has been talked a lot about lately, and lots of efforts and energy going into pushing in that direction, and that's going to add cost to fossil fuel generation, which will only help support geothermal energy costs. So getting to a point where I want to close out, but wanted to kind of mention a few very specific key areas of technologies that we see that need to be developed. This is kind of the grand finale of the presentation here, but these 6 areas that are listed here are kind of areas that need focus and innovation, and hopefully all of you are working on many of these things and thinking about this. But it's the full life cycle of geothermal development, from prospect identification to exploration, drilling, completion cost, lowering that, improving the reservoir performance, and figuring out how to apply the end use of that energy that's produced in the most efficient ways. So I wanted to share this slide, which is a technology roadmap, kind of explicitly defined, and wanted to kind of show some of the key technologies. I won't go through them all. You can kind of see them on the slide in terms of those 6 kind of focus areas and some of the key areas and technologies that need to be developed in order to drive down that cost. And again, the team has worked hard to identify what those technology areas are, and how we're going to get to that path of $45 a megawatt from where it is today on a historical basis at $75 a megawatt. So almost done, and I'll wrap up, but proven technologies can be deployed today that are on a technology readiness level of a 9 from oil and gas into geothermal, and actually and it can also go the other way around from geothermal into oil and gas, and those things can be very, very impactful already. And then there's a number of technologies that are under development, and in discussions of key partnerships with Criterion specifically, that'll be really impactful at a commercial scale, we think, in the next few years. And then there's even areas of research and ongoing development that we think are really going to be impactful in 2020, 30, and beyond, that make geothermal a great place to think about having a career and growing a career for the long term. So just finally, and I'll sort of close on this, and I apologize for going long, but there's a lot of merit and value in investing in geothermal research and technologies. There's reports and studies that have been published. This particular organization, Resources for the Future, has basically said that 25 times benefit to cost ratio of investing in geothermal is kind of the outcome, and that's far outweighs investments in other technologies that are aimed at addressing the key challenges of the energy industry. So tons of merit, tons of value in investing in geothermal, and we hope you all will take that on board and continue to advance the industry. So with that, I'll conclude and open it up for questions.
Thank you so much, Jenny. Thank you so much for the insightful talk and providing so much inputs about the utilization and how the exploration in geothermal is going on. And thank you for providing this new thing, which I heard really like for the first time, about cross-pollinating the technology from oil and gas to geothermal, conventional geothermal. And yes, we have got a couple of questions. I guess the talk seems really interesting to people. So I'll start reading questions. And according to time, I will see how many questions we'll be able to take. So the first question is about the questions from Majid. So how would these systems impact the cost of geothermal energy compared to traditional fluid systems? And yeah, do you have some comments on that?
Yeah, so the question is on advanced fluid systems in the industry. How does it impact the cost?
Yeah.
I think there's the advanced fluid systems that are being developed, and in some cases are also very costly. And so there's kind of two sides of the equation, right? It's making sure that the fluid system and the manufacturing and the cost of managing those fluid systems is cost effective, and then also what sort of efficiency can be achieved. So we like to kind of advertise that we can be 1.2 to I think as much as like 1.4 times as efficient with an enhanced fluid system. In terms of the amount of energy extraction that we can get out of the same rate of fluid. But when you think about what sort of cost that fluid needs to be at, it needs to be at or maybe only slightly in the order of maybe 10 to 20% more expensive than the fluid systems that are being used today, the working fluid systems, right, and the management of those working fluid systems. So I actually think that's maybe one of the bigger challenges, right? Is bringing down the cost of those fluid systems. But there's a lot of neat development going on in the nanofluid space for a lot of different industries, and other fluid systems that are under review. Supercritical CO2 has gotten a lot of interest and focus, and utilizing that for as a fluid system seems to have great potential. So I'm confident those costs will come down over time.
Thank you for your answer. So the next question is, which temperature degrees are good for the binary ORC power plants?
Which temperature is best for ORC binary?
Yeah, I'll read the question again. Which temperature degrees are good for the binary ORC power plants?
Yeah, if I understand the question correctly, it's about ORC power plants versus maybe flash power plants, and like what's the right temperature. So when you think about where produced fluid flashes under pressure directly from the well versus where it might be in a liquid format when it's produced from the well, and how that's applied. I mean, that's kind of the key constraint, right? Is can you actually flash fluid that's being produced out of the well under some level of pressure that can drive a turbine. So, for us, I think the real sweet spot for ORC binary is between 100 and call it 200 degrees C. It might be slightly less than that from an overall temperature, because you can flash water under I think at around 180 degrees C with just a 100 or 150 psi. But yeah, that's kind of the temperature range that I think binary ORC systems are really best suited for.
All right. So from this one, I have got a question. So how the content of gases and the fluid impact on the efficiency of the heat exchanger in the binary power plant? Does it depend on the temperature or the amount, or how does it impact?
Sorry, Anu, I'm not sure I caught the question. How does I know it's about the heat exchanger. Can you repeat the question?
Oh yeah, okay. So my question is like how the content of gases and the fluid, in the geothermal fluid, impact the efficiency of the heat exchanger and the binary plant.
Oh yeah, so in terms of like having like a two-phase fluid, right, versus a single-phase fluid through the heat exchanger, absolutely impacts the efficiencies of the heat exchange process. I'm not going to pretend to have an exact kind of any quantified numbers associated with that, but it does have an impact, and ideally, in a lot of our systems, we're looking at developing in sedimentary basins and conventional or traditional oil and gas fields. So expect to have gases, whether it's methane or CO2 in the system, and that combined with brine fluid, and that does affect the thermal efficiency. I don't know off the top of my head what that percentage impact is, but I think ideally we want to have a single phase and a fluid that not only has high thermal heat capacity, but it has a consistent heat capacity, so that we can design the system to be as fine-tuned as it can be to produce at the maximum efficiencies.
All right, good. Thank you. So because of time constraint, we won't be able to take all the questions, but we'll be taking one last question. So what specifically does the geothermal community need to change as we advocate for our technologies to ensure the growth projections become reality?
Yeah, so what technologies need to change, or
to ensure the growth projections become reality? Right.
Yeah, so I think the real key here is achieving scale. We need to drill a lot more wells, and through that process, we're going to learn a lot about what works and what doesn't work. And when I think about technology development in oil and gas, and how it's gotten to where it is today, it's been a process of many iterations and testing of that technology and those tools, and I don't think it's going to take as long in geothermal as it might have taken in unconventional oil and gas, or even in solar and wind development, because we have a lot of those technologies already developed that we can and those lessons already learned that we can take and apply quickly with a little bit of effort and development, energy and capital. So yeah, I think it's scale, and there's a lot of technologies that need to be advanced to achieve that scale. And you look at that technology roadmap that I showed, there's just several dozen kind of key areas that need to be addressed. But we'll never make advancements in those technologies if we don't get a chance to deploy them and prove and validate that they work. So yeah, I think scale is really the key. We need to drill a lot of geothermal wells.
Thank you so much for the answer, Danny. Yeah, and thank you so much for taking time for this talk. We really, really appreciate it. And thank you so much to all the attendees for attending this session. And you can follow us on the social media and keep supporting us. And have a great New Year and a Merry Christmas to everybody. Have a great vacations. Thank you.
Great, thank you.
Bye.
Bye.